Hi all, welcome to a new tutorial. Today we're going to look at the workflow from a concept line through to a panel breakdown on a facade of a building. Today we're going to utilise one of London's most iconic buildings, the Gherkin, as our precedent for this process. I'm going to break this down into 3 videos so we have enough time to go through the key concepts as well as go through some of the code behind the elements themselves. The first part of this tutorial is going to cover the basic form generation, as well as linking some Excel data and some initial panelization, covering things like referencing geometry, creating quick forms, linking external data to the model, information feedback along the way, as well as the initial panel breakdown. The second part of the tutorial is going to cover things like simple generated nodes, investigating polygon arrays, and then custom panel placements. The final part of this series is going to be identifying facade patterns, using functions with those patterns, simple facade panels, and we'll cover a summary and what the next steps might be. So, to give you an idea, we're going to start with this and we're going to end up with this. So let's get started. Welcome back. Hopefully that gave you a little bit of an insight into this iconic building that sits in the centre of London by Foster and Partners. To kick off this process, we open up a new GenerativeComponents file just based on the neutral metric seed. So the first thing I like to do is click on the Transactions tab and then turn on the automatic record transactions. I typically forget to do this most of the time, and what you end up is one transaction with all of your nodes inside it. So clicking on that is a great idea so you can troubleshoot later on. So the first thing we're going to do is click on the View tab and then attach a reference file. The reference file for this is just a 2D profile drawing that I sketched over an image from online to give us the profile of the overall building. The drawing itself consists of some arcs, which are actually tangential arcs, that form up the profile of the actual overall shape of the Gherkin itself. So there's a couple of ways we can use this. We can click on the Home tab and then click on Promote Element and click on each of those arcs and actually promote them to GenerativeComponents elements. But that would sort of detach it from this 2D reference file. And what I want to do is actually maintain this reference file so that we can actually, if we decide to change the profile for any reason, we can come back and automatically update the GenerativeComponents model itself. So with the profile referenced in, what we're going to do is we're going to click on the Point tool, and that's going to actually trigger the automatic creation of a base CS for us. So with that in place, we're just going to place 2 points, one at the bottom and one at the top, in the top view. Now this sort of is encasing the actual profile itself. I'm just going to change the X and Y values just to be a little bit more round numbers, so sort of 40,000, and I'll make the Y's translation, sorry, you can't see that, into 4,000. I'm going to change the Z value to -1,000, just so we keep that point well underneath the profile that we've drawn. So in the X translation here, we're at 5,000, and the Y translation will change to 5,000, and the Z translation has to be above the building, so we'll make that sort of 190,000. So we're working in millimeters here. So you can sort of see we've got 2 points, one that's at the bottom left and one at the top right. So from there, we just drag in a range box and connect these 2 points to the high and low points. And here you can see we've got a box now that's encasing our profile. And this is the key to actually using reference elements. We're going to actually utilize anything that's within that box. So first of all, we drag in an arc because we know we've drawn arcs. So what we can do is actually say, right, have an arc and use arc from range, elements in a range. And then connect that up to the range box. And you can see instantly what you get is actually all the arcs that were inside that range box turned into actually generative components arcs, which is brilliant. So now what you've got is the best of both worlds. You've got a reference file that has 2D geometry in it, and you're actually driving it into generative components objects. What we can do is if you didn't want all of those arcs, what you can actually do, you can actually click on this drop down box and scroll down to filter by colors and turn that on. And then within there, you can actually just type in, say, colors dot, and then filter through and find the color that you actually put the elements on. So color by, black or blue or other colors. Or what you can actually do is just type in the actual number. So the color number that you use to, say, in the picker from your color table. So here I've actually used 103, I think. And so you can see if I change it to, say, 104, 105 or whatever, it'll fail because we don't have any other arcs inside that box that actually are that color. So changing it back to 103. So okay, so now we've got those. The next steps we're going to look at is we don't want these arcs to be individual arcs. We actually want them to be a single sort of composite curve. So we easily just drag in a composite curve and say, or a curve, and then change it to composite curve, and then connect that up to the arcs. And now we've got a single composite curve made up of the arcs. And I'm going to rename this into something that I can understand. So I'm going to call it profile curve. What I tend to do now is I'll drag in a line node and actually change that to by start point, direction and length. I typically use these to actually generate, say, the center line of the building itself. So I'm going to attach that to the base CS. The direction for that is obviously the base CS.z direction. And the length for this, I'm going to make it, say, 200,000 because I know that's higher than the building. So you can see now I've got a line that shoots up past the building. It's the center line of the building. So I'll rename this center line. So to show you how you might utilize this simple system is I might drop in another line and just by points and select the base CS as one point, and the other point I'm going to actually use the profile curve that we just set up. So in here and type in profile curve and dot, and what we want it to be is the start point of that curve, so we can target the start point. So, and now we get a line just at the base that filters those in. So now because I know this building is a circular building, I'm going to drag in a circle and I say circle by center and radius. So now we have the center point. It's going to be the base CS for this. The radius for us is that line that we just drew. So now we can just use that, say, line 1. So we can link up line 1, link up there. And now we can just dot, and we'll put that length, because now we want to pull the length from that. And the support for that, actually we need to tell it what direction it's going to be. So we can type in base CS dot, and then make it XY plane. That just tells it the direction that you want this circle to be, what orientation you want it to be. You want it to be in the XY plane. I'm going to drag in a B-spline surface and change that method to a sweep cross-section along path. And the path itself is going to be my circle, and the profile is going to be my profile curve. And you can see instantly we have a Gherkin shape straight away, which is perfect. So once we have that surface, we could say drag in a point node, and we could change that to say put some points on it by points by UV parameter on curve. And we can do that when we type in some UV parameters and pull in the surface and have some points and generate some nodes. But we're not going to do that for this. We're going to hide all of these because we want to produce this in a different way, because we want to control exactly where these the facade panels actually sit on the building itself. I found one method that I like doing is I pull in a plane, and we're going to start generating planes that are on a distance along that center line. So I'm going to change this to by distance along curve and connect that to the center line. So for the distance, I'm actually going to drag in an Excel range node. So drag in Excel, and then you select the Excel workbook you want to reference from. So click on that, and I've got one called Gherkin Levels, which I've just got some RLs in. And then from there, you just nominate what sheet it is. So in inverted commas, just put the name of the sheet. So I called it RL. And for the range address, just in inverted commas, you just type in, say, A2, semicolon to A34. And that will reference, obviously, all the A column between 2 and 34. And hitting enter, then that opens up the file for you to show you what you've done. You can also link that now straight to the distance, which fails, but all you gotta do is a top dot value in there, and it'll actually pull in those values straight from Excel. Now if you zoom in, you can have a little bit of a look, and you can see exactly that it's actually placed all of those planes evenly spaced or spaced based on the Excel spreadsheet up that center line. So that's perfect. So now we've got planes divided at our floor levels. So from there, what I'm actually gonna do is just change that planes to actually call them floor planes, because now I know that they're actually where they are. It's the floor planes. And drag in a point node and change that to at plane curve intersection. And obviously just connect that to the planes and connect that to my profile curve. And so what I'm getting now is basically every time one of those planes intersects that curve, you get a nice little point on this curve, on the arc. So from there, I'm just going to drag in a line node, and then basically connect from the floor planes out to that point 3. And similar to what we did before, now what we can do is basically use all of those lines to actually generate some circles. So again, we just go over and grab our circle node, drag that in, and we want our circle by center and radius. And then we can select the floor planes as our center point, and the support is also the plane, because the plane has a direction, and link that radius to the line, and then just change that to dot length. And there you go. Now you've got circles placed at the right radius as it goes up and follows that curve. The great thing about this is you can actually add in an expression and link that in to the actual circle itself. And all you need to do is just go and type circle dot and put area. And instantly you get an area feedback for every one of those circles. So now you can, with some basic geometry, start to get the floor area of your building straight away. So from here though, what we're going to do is drag in some points, another point node, and change that to, say, a number along curve. And we're going to link that to the actual circles, because we want to generate some points around these circles that are actually going to generate our facade panels. Now the number of points along that curve, we want to sort of make that a variable. So what I'm going to do is type in, say, panel number, and type in, which sometimes turns into parameter. But so you type in, say, facade panels, and then put equals, and then put a number in. And what that does is it automatically generates a variable for you. So now you've got one called facade panels, and it's just got a static variable called 20. And for now, we're going to increase this later, but for now that's perfect for what we need. So the next thing we do is just drag in a polygon node. And for this, I want to check that all my polygons are actually planar. So before I sort of get too carried away, I'm going to drag in an expression, and then link that expression to my polygon, and change that to polygon.isPlanar. And what that's going to do is actually give me a true or false to let me know whether my polygons are actually planar or not. So now what I can do is actually change these polygons to by point grid, and then select the points that I just created. And it's called point 4, and then wait a few seconds, and there you have it. And they're all true, which means they're all planar polygons. So now what we've got is the starting basis of our sort of Gherkin model. We've got polygons that are actually set on each of the floor panels, lining up with the floor joints. They're all planar, and we've got the ability to easily change it using the facade panel variable we've introduced. And moving into the next part, what we can do is actually use this base polygon as the starting point to create our diamonds and triangles. So stay tuned, and next time we'll come back and we will start to create some diamonds. Thank you. If you like this video, please subscribe and click on the bell so you'll be notified when the next part of the series arrives. Thanks again for watching, and I'll see you next time.